Hello.
Hey, Kasha, how are you?
Hi, how are you doing? So we're now going to Europe and going to America where it's more of a normal time for people. So lovely to have you on the stage. Thanks for joining. And Alan is going to be, at least the title I have, he'll be telling us about recent trends in conductive inks for printed electronics.
Yes.
Um, Brilliant. So when you're ready, please share your slides. That's it. Well, good luck to you, Alan.
All right. So, like Kasha said, I'm Alan Brown from Nagase Chemtex, and I'm going to talk a little bit about conductive inks. Give a short introduction on Nagase Chemtex, then we're going to talk about inks for medical applications, a low-cost conductive ink, and wearable inks. A little bit about Nagase Chemtex. So, Nagase Chemtex was previously Engineer Material Systems, EMS, which was founded in 1993. We began manufacturing and got ISO registration in 95. We were acquired by the Nagase Group in 2012, and then we recently changed our name to Nagase Chemtex America in 2021. So many of you may previously know us as EMS ECM. And then, like I mentioned, we're located in Ohio with 53 employees. As far as Nagase Chemtex is concerned, we have our facility in Ohio, 109,000 square feet, and I will show you that facility a little bit more in depth later in the presentation. And then we also have partner companies in Himeji, Japan, and Wuxi, China. First, we'll talk about medical applications, and then, general materials and processes used for these applications are silver chloride and carbon screen printable inks, and then, a dielectric ink for environmental protection. Generally printed on polyester, polycarbonate, PVC glass. Another substrate I probably should include here is TPU as well. The inks, they require high sensitivity, and then they've got to be compatible with sensor reagent inks. With silver and silver chloride products, we start customers generally with 4 different products, and it really depends on the application. For ionophoretic applications, usually a higher silver chloride ratio is required. So that's where we'll start with like a CI 4001 material. General electrodes, more in the 80-20 range with the silver chloride ratio. And then you see 3 different product selections there, and that's going to be dependent on the requirements of the application, of which we'll get more in touch with. Why I say different applications is one of the trends we've been getting asked a lot about is how do the silver chloride materials interact with hydrogel? And reason being is the ink can be packaged with the hydrogel. That way it's ready for immediate use with a patient. These hydrogels can be aggressive to underlying inks as time passes. So what we do is we screen print electrodes in-house, and we will test them with hydrogel, and we want to ensure that they have low impedance. And what you're seeing here is just how we construct the electrodes. Usually is silver, and then with the silver chloride, and then we can also use carbon as the circuit as well. And we'll face them we'll place the sensors facing each other and put the hydrogel in between, and we'll measure impedance. One of the things we were asked to do is, what is the shelf life when these inks are stored with the hydrogel? And what you see here is sensors being aged at 65C with a commercially available hydrogel. And for this particular test, it was required that the impedance not exceed 2K ohms at 10 hertz. I show 2 different ink combinations here, one of which is very good at staying in the required impedance range, and being CI 1091, DI 7509, and CI 4047, and getting up to about 1,500 hours at 65C. We're up to about 2 years of shelf